Astronomers are trying to understand where our solar system came from, how life got started here, and where else in the galaxy life may be lurking. Chemistry is very important in these processes, both in terms of providing chemical building blocks from which things can form, but also providing chemical signatures that highlight that something, like life, is happening. We had thought that one compound, called methyl chloride, was a surefire sign of life, but now astronomers in America and Denmark have detected the same chemical around a star without any planets, as well as on a comet found in our solar system. I heard from Jens Jorgensen from the Niels Bohr Institute at the University of Copenhagen how they collect this information from space.
So what we do is that we use large radio telescopes to basically search for the fingerprints of molecules around these young stars. What was quite surprising here is we found for the first time a sign what's called an organohalogen. What that means is that it's an organic molecule, so it has some carbon in it, and this carbon was then bounded with a chlorine atom. So this is the first time that has ever been seen in interstellar space, and we could then securely identify that towards such a young star. It's about 400 light years from us.
And so, what do these organohalogens actually tell us?
Yeah, so that was what the interesting thing about this particular molecule. It's called methyl chloride or freon 40. Some people have been suggesting that this molecule could be an indication of life if we were looking atmospheres on planets away from our own solar system.
Can we see these organohalogens on Earth?
Yes, and that's actually one of the reasons that people have been proposing that this one here could be an indication of life around a distant exoplanet. Basically, things like methyl chloride is produced in very high abundances, both by living organisms on Earth, but also through industrial processes. So that was why people were saying, if you see this molecule here around an extrasolar planet, that could be an indication of life. But what our study here then shows is that, well, there are also regions where planets still haven't formed, so we have to shoot that one down, unfortunately. Of course, this is one small brick in a much bigger puzzle here. And you can say maybe it's disappointing that we then rule out that methyl chloride can be used as such a biomarker. But the fact that we see it both in the protostar and in our own solar system, it's really telling us something about this very important organic chemistry that takes place during star and planet formation.
Now, this is something that's 400 light years away, this star system. But, I mean, is this the only place where we might be able to find this compound?
Well, I think that we have hopes of actually trying to find it towards other of these young stars. We can basically go out and search towards similar systems, but this is the sort of the best candidate we have for such a thing. However, there was another thing in this new discovery, and that was that we used data from the Rosetta mission, the Rosina instrument on the Rosetta mission. Rosetta was a small spacecraft that went out to a comet in our own solar system just a few years ago. And in those data, they actually also found evidence of this particular molecule. So when we said go out and try to take a look for it, they actually did and were able to find it. And what's really interesting is that we think that comets like this comet 67P is sort of a relic of the very early stages of our own solar system. So the composition of this comet here is actually telling us something about what was the chemistry at the time that our own sun was actually born.
Okay, so why exactly is this important and where do you see this research going in the future?
Yeah, so for us, the big question is really how complex can this chemistry actually become up to the stage where planets and comets, for that matter, are actually forming. So it's really the question of trying to say how common are these molecules actually around other young stars, and thereby also what are the chances actually that some of these extrasolar planets actually may have life, in fact.
That was Jens Jorgensen from the University of Copenhagen, and you can find out more about that study in Nature Astronomy.